The topic is C-scan, presented by D. Aishwarya, 22B01A0533, E. Sahiaja, 22B01A0538, under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSC, SVCW, Bhimavaram. Disk scheduling, C-scan. Disk scheduling. Disk scheduling is a fundamental concept computer storage systems that involves determining the order in which read and write requests to a hard disk drive are serviced. The goal of disk scheduling is to optimize the movement of the disk's read or write head to minimize seek time and maximize overall system performance. There are several types of disk scanning algorithms used in disk scheduling to determine the order in which read and write requests to a storage disk are serviced. These algorithms are designed to optimize disk access and seek time. Here are some common types of disk scanning algorithms like FCFS, SSTF, SSCAN, CSCAN, Look, CLOOK, FSCAN, N-step scan, and multi-level queue. CSCAN disk scheduling algorithm. Given an array of disk track numbers and initial head position, our task is to find the total number of seek operations to access all the requested tracks. If a CSCAN disk scheduling algorithm is used, the circular scan scheduling algorithm is a modified version of the scan disk scheduling algorithm that deals with the inefficiency of the scan algorithm by servicing the requests more uniformly. Like scan elevator algorithm, CSCAN moves the head from one end servicing all the requests to the other end. However, as soon as the head reaches the other end, it immediately returns to the beginning of the disk without servicing any requests on the return trip and starts servicing again once reaches the beginning. This is also known as the circular elevator algorithm, as it essentially treats the cylinders as a circular list that wraps around from the final cylinder to the first one. Advantages of C-scan circular elevator disk scheduling algorithm: works well with moderate to heavy loads. It provides better response time and uniform waiting time. And there are other advantages. C-scan algorithm is the successor and the improved version of the scan scheduling algorithm. The head move from one end to the other of the disk while serving all the requests in between. The waiting time for the cylinders, which were just visited by the head, is reduced in C-scan compared to the scan algorithm. Uniform waiting time is provided. Better response time is provided. Advantages of C-scan circular elevator disk scheduling algorithm. It has more seek movements as compared to the scan algorithm. May not be fair to service requests for tracks at the extreme end. And there are other disadvantages. More seek movements are cost in C-scan compared to scan algorithm. In C-scan, even if there are no requests left to be serviced, the head will still travel to the end of the disk, unlike scan algorithm.
C-scan disk scheduling algorithm. The circular scan C-scan scheduling method is a modified version of the scan disk scheduling technique that improves the scan algorithm's performance by more uniformly processing requests. Like the scan algorithm, C-scan moves the head from one end to the other, processing all requests. In this algorithm, the head or the pointer only moves in one direction, which means the scan searches for requests at the end of a direction and then jumps to other end to service the request in the same direction. Are the steps of algorithms. Step 1. Let the request array represents an array storing indices of tracks that have been requested in ascending order of their time of arrival. Head is the position of the disk head. Step 2. The head services only in the right direction, from 0 to the disk size. Step 3. While moving in the left direction, do not service any of the tracks. Step 4. When we reach the beginning left end, reverse the direction. Step 5. While moving in the right direction, it services all tracks one by one. Step 6. While moving in the right direction, calculate the absolute distance of the track from the head. Step 7. Increment the total seek count with this distance. Step 8. Currently serviced track position now becomes the new head position. Step 9. Go to step 6 until we reach the right end of the disk. Step 9. If we reach the right end of the disk, reverse the direction and go to step 3 until all tracks in the request array have not been serviced. Example for this algorithm. The question is, consider a disk with 200 tracks 0 to 199 and a disk queue with the following input or output requests 75, 90, 40, 135, 170, 65, 10, 45. The read or write head's initial position is 55 and it will move to the right hand side. Using the C-scan method, determine the total number of track movements of the read or write head. Graph for given example. So the total head movements, the initial head point is 55 and when we calculate the result is 393. Another example for the given algorithm, the inputs are requested sequence equals to 176, 79, 34, 60, 92, 11, 41, 114, and initial head position is 50. Direction is right direction. We are moving from left to right. And the output must be initial position of head is 50. Total number of seek operations is 389. Seek sequence is 60, 79, 92, 114, 176, 199, 0, 11, 34, 41. The following chart shows the sequence in which requested tracks are serviced under scan. So the total seek count is calculated as the given below, and that result is 389. Let's see the implementation of the given algorithm. Implementation of the C-scan algorithm is given below. The distance variable is used to store the absolute distance between the head and the current track position. Disk size is the size of the disk. Vectors left and right store all the request tracks on the left hand side and the right hand side of the initial head position respectively. So here we see the code for the algorithm. We first initialize the size and then the disk size.
Let's see the next part of the code. Appending n values which has to be visited before reversing the direction. Tracks on the left of the head will be serviced once the head comes back to the beginning. Sorting left and right vectors. First, service the request on the right side of the head. Now, appending current track to seek sequence, and then to calculate absolute distance, and then to increase the total count, and axis track is now new node. Once reached the right end, jump to the beginning, adding seek count for head returning from 199 to 0. Now service the requests again which are left. Appending current track to seek sequence and then calculate absolute distance. And then increase the total count, and axis track is now the new node. Then we use for loop for in I equals to 0, I less than seek sequence, and I plus plus. Finally, the driver code is first initialize the array size with 8, and the numbers are 176, 79, 34, 60, 92, 11, 41, 114, and then we initialize head with number 50, and then the initial position of head is 50. Total number of seek operations are 389. The seek sequence is 60, 79, 92, 114, 176, 199, 0, 11, 34, 41. So this is the code for C-scan scheduling. So we have discussed the topic disk scheduling, the advantages and disadvantages of C-scan, and then the algorithm steps, and then examples of C-scan, and then implementation of the code in C-scan.
Thank you.